Hey there, folks. It's Mr. Kidos, and I am doing this semi-live. I am not going to do anything. I'm just going to use what I have right away. So it is another chance for us to kind of see how things are going. Pretty cool, huh? Already made my first mistake. Dang it! All right, so let's try this again. Whoa. And it is time for me to do this yellow thing here and say, what the physics is going on here? All right. Anyway, uh, there are some questions about. Um, uh, let's see. Let's go ahead and transition over to um, this so I can go there. Let's go ahead and delete that. Boo. All right. So the question was, what's the difference between distance, displacement, speed, velocity, average speed, average velocity? And I had you guys do an activity on physics classroom. So let's take a look at one of the examples here. So the idea is that this one in particular is asking for how far it goes. So we really have to pay attention to what it's saying up here at the top. So understanding that, we have to understand. So distance is about the path. So distance is all about path. Distance is all about the path. So that means I have to go through each of these segments and add up how far it has gone for each segment. So this one starts from 0, goes to 14. At time 0 it's at 1 and goes to 14. And so that means that that's 13 meters for the first part. And then it's going to go from 14 to 5. That's another 9 meters that it travels. And then the last segment, it's going from 5 to 10 meters. So that's another 5 meters. I add those all up, and that's my answer for distance. So distance, I have to add all the displacements. I have to add up all the distances the object went through to do that. Displacement, way easy. For first 10 seconds, all I have to do is look at the beginning, which is right there, and at the end, which is right there, and subtract the two. And I can see that I ended up further along the positive axis, so that means I'm going to have a positive answer. So looking at that, I'm at position 10 meters at 10 seconds. And at 0 seconds, I was at 1 meter. So my displacement is positive 9 meters. Cool beans. Another thing is, to find the speed of any one of these segments, I just need to find the slope. Now, and tell you what that is. So like this first one right here is going up to 14 from 1, so 13 in 2 seconds. So that one is going to be 6.5 meters per second. And over here, it's going down. So my velocity in the first part is 0.65 meters per second. I can look at the velocity of the second part and compare, find the slope of that. That'll be a negative and so on. Now, if someone asked me to find out what the average velocity for the first 10 seconds was, well, that's cool because I can just look at, again, the beginning and ending. I went 9 meters, and it took me 10 seconds to do that because 10 minus 0 and 10 minus 1, I get 0.9 meters per second. That's my average velocity. Now, if it asked you for average speed, you'd be just like you're kind of upset about distance. I have to add up all those segments. Kind of same thing. What's the total distance it traveled? Well, we figured that was 27 meters. And how much time did it take? Well, it took 10 seconds to do all that. So my average speed is 2.7 meters per second. Now, my average speed tells me more kind of what the object was kind of doing on a whole time. It was moving the whole time. My average velocity only cares about the beginning and ending. So distance and speed care about the path you take. Displacement and velocity care about just beginning and endings, if I'm talking about average velocity specifically. So hopefully that was helpful. and so on. So pay attention to things, words like, oh, what's this at a particular time versus what is this between this time, and so on. The last one was something about predictions. Let's just say I want you to predict where this is going to be at 14. Now I can't go to time 7 and figure out that's at 9 meters and double that. It's not going to be at 18 meters because you're assuming that started at 0. It didn't. It started at 2. So if you can figure out how much distance it covers in a time that's related to 14, then you can use that to figure out how much more distance it will be for another 7. So an example, in the first 7 seconds, which is half of 14, right? Let's go with your idea. This is 9 meters. This is 2 meters. It's traveled 7 meters. So in another 7 seconds, it'll travel another 7 meters. Hey, isn't that going 1 meter a second? Yes, we'll come back to that. But the idea is 7 more meters from where it is at time 7. So that means it's going to be at 18. Kind of cool. I'm sorry. It's going to be at 16. Can't do math. 9 plus 7 is 16 meters. So that's exactly where it's going to be. Right? It's not going to be at 18. Okay? We're off by 2 meters. That offset is super important. So this would be that case. Another way to do it is you found the slope. That's how much it's doing. So it's going to change by position 1 meter every second. So in 14 seconds, it's going to change by 14 meters. But it started at 2 meters, so it's going to be at position 16 when you're done. All right. The math for that looks way more complicated than really it is, but this is exactly what we're doing. We found the model. Position is 1 meter per second times time. Again, that's the slope, and our initial position was 2 meters. So we have started kind of doing that. Now from there, we're going to go and say, hey, I want to know when t equals 14 seconds. Well, I'm going to plug that in and go 14 seconds times 1 meter per second. Seconds cancel out, and then I got to add 2 meters, and I end up with 16 meters, which is 14 plus 2 is exactly what we figured out the other way. The other thing is it asks you what time will it be at a particular position. So let's say what time will it be when it gets to 20 meters. I just picked a random number. Now I can't say 16 because at 10 meters it's 8 seconds. I can't say 16 seconds because it's not proportional. It's linear, which means I have to use the same equation. Using the equation, what I'm going to end up doing is I have the same slope times time plus 2 meters. Instead of plugging in time, now I have position. What did I say, 20 meters? So when is it going to be at 20 meters? Well, I have to solve for t. So I subtract both sides the initial position. So I know the displacement is going to be 18 meters from where it started at 0. And it's going to do that at a rate of 1 meter every second. So something times 1 equals 18. That means that it's going to be at time equal 18 seconds. So hopefully that helps. And I hope you enjoyed this crazy video. It might have been a little long. Let's go ahead and put me back to my fun webcam here. Woo! So hopefully that helps you out with whatever else needs help with. Yeah. So this has been a quick, brief, what the heck is going on with physics? Oh, what the physics? Bye.